What is the voltage produced by a voltaic cell consisting of a zinc electrode in contact with a solution of ionic zinc and a silver electrode in contact with a solution of Ag plus ions? So we have two half reactions. We need to write both of them. On one side we have Zn2 plus 2 electrons. It's going to give us Zn in solid phase, this one in aqueous phase. And the second one is going to be Ag plus electron. It's going to be Ag solid. Try to write both half reactions when you are dealing with finding standard cell potential, both of them in terms of reduction reaction. Then you can go to the table called standard reduction potential and find out the corresponding value for these two half reactions. For the first one, that's going to be negative 0.76 volt, and for the second one is going to be 0.80 volt. After that, we can find out the anode and cathode. Let's find out which one is anode, which one is cathode. Cathode is where reduction happens, and anode is where oxidation happens. Reduction happens when we are dealing with a stronger oxidizing agent. How do we figure out which one is stronger? We need to look for these two numbers. Whatever is greater, that's going to be the stronger oxidizing agent, which in this case is going to be silver. So 0.8 can is greater than negative 0.76, so it means that silver can oxidize zinc, but zinc cannot oxidize silver. So cathode is going to be silver and anode is going to be zinc. If you want to find out the standard cell potential, you're going to say standard reduction potential of the cathode minus standard reduction potential of the anode, which will be 0.8 minus negative 0.7, and that will be 1.56 volt.